Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll talk about circles and their equations. Now a circle is a collection of points that are a certain fixed distance away from a point called the center. That distance we label as r for the radius, and the center we typically label as hk, like I've shown on the screen. Now again, it said each point on the circle is the same distance from that center. So using the distance formula, the distance this time being the radius r, we have the square root of x minus h, the difference between the two x coordinates squared, plus parentheses y minus k quantity squared, all inside the square root. The difference between the x coordinate squared and the difference between the y coordinate squared. Total together, the square root of that is equal to the radius. Now we can square both sides of this equation, and that's where the equation of the circle comes from. X minus h quantity squared plus y minus k quantity squared equals the radius squared. So any point xy that's on the circle has to satisfy this equation. If we know the equation, then we know the center and the radius, and we can sketch the graph of the circle. If we have the center and the radius to begin with, we can work our way backwards to the equation that comes from it. So this bit that I've done here so far shows you how the distance formula and the circle are related, but this is really a Pythagorean theorem problem as well. We can make a right triangle out of this. And so resketching that, it looks like this. Here's HK. Here is some point on the circle XY. And we can draw a right triangle here. And that tells us that from the Pythagorean theorem, the square of the two legs added together has to equal the square of the hypotenuse. The base of this triangle, that's the difference in the x coordinates. That's x minus h. The vertical height is y minus k, and there's our radius. So x minus h squared plus y minus k squared equals r squared. Pythagorean theorem, distance formula, circles, all intertwined. All right, so let's work through some of these problems. The first two problems say find the equation of a circle with the given center and radius. So when the center happens to be the origin, it's a special case of this. Again, let me just jot down the equation again. Quantity x minus h squared plus the quantity y minus k squared equals the radius squared. So when we subtract 0 from x, x minus 0 is just x. So the equation is going to be x squared plus y squared, same thing with y, equals the radius squared, and 5 squared is 25. That's the equation of a circle centered at the origin with a radius of 5. And again, the 25 comes from 5 squared. X squared was originally x minus 0 squared, and y squared was y minus 0 squared, but subtracting 0 doesn't change anything, so we can just ignore that part. That's a special case centered at the origin. For the rest of the cases, we use the formula at the top. Here, the center, 3, 2, that's my h and my k, and the radius, r, is 3. So substituting into the formula, that's going to be x minus 3 squared plus y minus the y value of the center, y minus 2 squared, equals the radius squared, which is 9. 3 times 3 is 9. That's the equation of that circle. Keep in mind that if either h or k or both were negative, when you subtract a negative number, it's the same as adding a positive number. So if that center was negative 3, 2, x minus negative 3 is the same as x plus 3. Right. Problem 3 and 4, we're going to graph equations. We're going to graph circles from the equation. The first one, x squared plus y squared equals 16. That tells me that hk is 0, 0. Also, I know that the radius squared is equal to 16. So the radius would be the square root of 16, or 4. And the best way to graph these, and let me just blow this up a little bit. I'm going to recopy the information. The center is 0, 0, and the radius is 4. Start by putting a point at the center. Then count 4 units to the right, above, to the left, and below. And those are 4 points that are on the circle because they're all 4 units away from the center. Then we draw our best circle through there. That was so-so. I'm sure yours is better. Let's try another one. This time we've got a circle of this form. X plus 2 quantity squared plus y minus 1 quantity squared equals 36. So x plus 2 is really the same as x minus negative 2. And so the center here is negative 2 comma 1. What you want to look for is what's being subtracted from x and y. And here that was negative 2 and 1. R squared is 36. That tells us the radius is the square root of 36, and that's equal to 6. So we're going to draw a circle whose center, again, was negative 2, 1, and whose radius was 6. Start by putting a point at the center. Negative 2, 1 is 2 to the left, up 1. And then we count 6 units to the right, above, to the left, and below. And then those 4 points, we're going to draw a circle that goes through. Not bad. I'm sure yours is better. Anyway, that is how we graph a circle from its equation. And that's also how we can create an equation if we know the center and the radius. In the next video, we're going to start with equations that are not in this form, but we'll convert them to this form by using completing the square.